Hello, everyone. Welcome back to my channel. Today, I'm going to do an algorithm question, which is three-sum closest. Okay. So the question is that given an integer array nums of length n and an integer target, find three integers in the array such that the sum is closest to target. Okay, and you should return the num of the three integers. Okay. So when I see this question, I think the most direct solution that comes to my mind is, of course, brute force. Basically, you have a three-layer nested loop, and you find out all of the possible combination of the triples in the array, and then you sum each of the triple, and then you find the closest one. So that's the most straightforward solution that can lead you to the correct result, but I don't think the time complexity is very optimistic there, because it will cost you a cube. Okay, so there must be faster ways to do it. So if you think about it, actually, they don't really mention that the array is sorted or the list is sorted, right? So first thing we can do is, of course, sort this list. It will rank the elements from the smallest to the largest then. Okay, so after that, I think, okay, so the overall solution, the overall direction I would go for is, because right now it's ranking from the smallest to the largest, then you want to avoid the situation that you need to iterate through three nested loops. Then you can basically fix one layer, right? And then you choose a starting point for each given fixed layer, outside layer. And then what you do is that you move the rest of the two pointers to find out the closest possible sum. Okay, so for example, let's go through this example given here. So if we look at this one, after sort, it will become 1, -4, -1, 1, okay, and 2. So basically, you still need to loop through one layer as the most as the outer iteration. Okay, so the first thing you would go is that you choose -4 and fix it, right? And then you put the left pointer and the right pointer at the two ends of the inner side, which is -1 and 2, right? You need to find two elements in the remaining part of this array, which will be put together with the fixed element. Then you want to find two that sum together with this fixed one that could be closest to the target here. Okay. to the target value here. So, so now you can basically, for example, add up -1 and 2, right? The value will be 1, and then add -4 on top of it. The value will be -3, right? So in this case, the target value is 1, and for -3, it's a little bit far away. So, and it's actually less than the target, right? So the first iteration, you do -1 and 2, and these 3 sums up to -3, which is less than 1, okay? Because it is less, and you know the array is an increasing order, okay, ascending order. So basically what you can do is that you move the right pointer to the left, okay? So the next iteration you would do is that the left pointer is still at -1, and the right pointer is going to be 1, okay? And in this case, the sum will actually be -4. Oh, sorry. It is less than 1. You should move the left pointer 1 position to the right, okay, so that the overall sum would be increased. So in this case, you would move the left pointer to 1 actually, and the right pointer still stays at 2. And in this case, the sum is going to be -1, which is still less than 1, but we get 2 closer to the target value, okay? So in this case, difference is 2. In this case, the difference is 4. Then the second one is definitely better than the first one. And we go to the next iteration, okay? So what we do is that we fix -1, and the left pointer and the right pointer have to be 1 and 2 accordingly, okay? And in this case, the sum is going to be 2, okay? Which is greater than the target value, which is 1. But we get 1 step closer because the difference is only 1, which is smaller than 2, okay? And that's it for the current iteration, and you cannot move the outside layer further to the right because in that case, if you move it to 1, then you don't get two values remaining, right? So you have to stop at this position, which is 2 positions ahead of the end of the list, okay? So yeah, basically we get this difference as the smallest difference of all possible combinations, and then eventually we should return the sum as 2, okay, which is the expected answer here. Okay, so that's the basic thought. I think in that case, we can write up the code. So we can keep current value, current sum. Let's do current sum, something like this. That's the value we are going to return, okay? What should be the initial value? Okay, let's set it up to be null, okay? Then let's write up the loops here. Remember that we need to be 2 positions left to the end of the array, okay? And in that case, we choose the left pointer and the right pointer to be one position to the right of the fixed pointer, and then the end of the array. So it's going to be okay. If left and right are different indices, then basically we can always move to find the next possible combination. Okay. So let me think. Okay. Okay, I think I need to set up the current value. To a different value, but okay. So in that sense, we have the combination actually, let's call it closed sum. And then here, current value is equal to I plus right. Right? And we need to decide, okay? Actually, we need to decide if this is a better combination or not. So if current, okay. So target that sense if it's less than okay, that means the current combination, the current triple chosen is actually a better one. Okay, so in that sense, we need to actually update the according value. Or, so if the current sum, closest sum so far hasn't been assigned a value, then we have to assign it an initial value, right? Okay, right now we can just update the closest sum. That's going to be okay, the difference of the current iteration. Okay, and the next step, we need to decide how we move the pointers in the inner loop. Remember that if the current sum is smaller, if the current sum is smaller than the target value, then we should expect it to be increased in the next iteration. So we can get closer sum, closer possible sum potentially, okay? So if current, okay, is equal target, then basically we can break and just return, right? Else if current is less than target, else if current is already bigger than target, you move the right pointer one position to the left, okay? Okay. I think after the current iteration here, we should have something that is optimal. For the sum, let me just do a test run here. So the values here 0, 0, 0, and current minus target. The output is 1, expected value is 0. How come it is 1 actually? Okay. Print the current, see what is happening. It's 0, okay. Okay, so this value should be current rather than difference. Okay, and in this case, we just passed the test. I don't think there are any edge cases here. Okay, because we are actually going through all the potential candidates for the optimal triples, right? So this should always give us the most optimal combination here. So let's try and give it a submit. Okay, nice. My answer is accepted. Okay, great.